Thank you for attending this session. I'm very excited to be here at KubeCon, Cloud Native Con, virtually. And today I'm going to tell you about a different approach to upgrade your Kubernetes clusters. Maybe it's different, maybe it's new. A blue and green approach, as opposed to having an in-place upgrade. So I'm going to start with a couple of questions. How many of you have had to upgrade a Kubernetes cluster in the last few years? I would imagine quite a few people in the audience. Kubernetes is a very popular tool and project. It's being used in a lot of different organizations. So you probably run into this problem more than once. Another question is, how many of you have had to do these upgrades and have had no issues at all? I would imagine not that many people. Kubernetes is a distributed system and it has a lot of different components. So it's a complicated system. So this is what the talk is about. A little bit about myself. I work at Rakuten and I'm an SRE manager there, and we run Kubernetes clusters in several environments. I'm also a co-chair for the CNCF SIG runtime, and I've been a Kata containers contributor for the last couple of years. Some of what we'll be talking about today includes the Kubernetes components. We'll briefly talk about the control plane and the data plane. Then we'll talk about some of these upgrade problems, then some solutions to these upgrade problems together with some tools, then what it might look like in production, having all these tools together with the solutions, what it may look like in terms of the tools and approaches in the future as far as these upgrades are concerned. And finally, I'll provide some takeaways. So the Kubernetes control plane. So typically you have either a 3 main node setup or a 5 main node setup. I changed the terminology here from main or from master to main. So in every main node, you have all these different components. You have the API server, you have a scheduler, you have the cloud controller, controller manager, so several different components. Now, when you have a Kubernetes version, let's say you have 117, all of these components typically have that same version. API server is 117, scheduler is 117, and so forth. So that's a recommended way of running Kubernetes. It doesn't mean everybody does it that way, but that's what you typically have. Similarly, the data plane also has its components with its own unique versions. So the data plane consists of your Kubernetes nodes. In each node, you have your kubelet, you have your kube proxy. You may have other components like your container runtime or some other specific things. And if you have a version there, Kubernetes version 117, that will be also the version of your kubelet and your kube proxy. So you have these matching versions. So that's the control plane and the data planes for Kubernetes. So what are some of the upgrade problems that you can run into for your Kubernetes clusters? So this is a tweet from last year from Stefan. And basically he says, I upgraded GKE from 113 or to 113. And he had Istio running 1.0 and then went over to 1.1. As soon as he did that, components started crashing. Some of the TLS handshakes started to time out. So these are the type of things that you may run into. And then he had to start the things in a special order to make it work. So the problems are related to several things. You have different Kubernetes API versions that change between different major Kubernetes versions. So you have the alpha, then you have beta, and finally, when, say, a release or a resource is promoted, it becomes stable. So it goes from V1 beta 1 to V1, for example. Then the cycle goes like this. You have an API group. It goes from V1 alpha 1, and then it keeps upgrading until V1 alpha 2 and alpha n. And then when the community decides that it's beta-like, then it gets promoted to beta, and that becomes beta 1 until beta n. And finally, when the community decides that it's stable, it decides to promote it to V1. And then the cycle continues for V2. So V2 alpha 1 and V2 beta and so forth. So another problem here described in the release notes for Kubernetes 1.17. So you have the RBAC V1 alpha 1 and V1 beta 1 are deprecated, and they will be completely removed in 120. So in favor of V1. So that means if you have API definitions, resources, RBAC resources with V1 beta 1 or V1 alpha 1, when you upgrade your cluster, some of these resources may not work. Maybe some of your pods may not work. Some of your users may not be able to log in. So another problem described here, it's Kubernetes plugins. In this case, AWS EBS. It says that it will be completely removed in 121 in favor of CSI, Container Storage Interface. So if you have that plugin with AWS EBS, maybe you have some volumes like EBS volumes running in your Kubernetes clusters, and you upgrade to 121, you'll have unpredictable results. Some things are not necessarily going to work. So this is the RBAC example. So if you have 117, and let's say you go to 120, when V1 beta 1 is removed, so you forget to update that definition, you restart your cluster, maybe your users are not able to list pods or see the pod logs. So basically your cluster is not happy. Some things will crash. So ideally, you want to do this ahead of time, right? So you want to change the definition from V beta 1 to V1. So by the time you do that upgrade, everything is great, nice and happy. You're able to log into your clusters, etc. So Kubernetes has several components, and each one of these components have several versions, just like I described before. So you have maybe Kubernetes API 1.17, and it only supports certain versions queues. So the kubelet 1.16 and 1.17 will be able to connect to 1.17 with no problems, or the way it's supported. But if you have something like a kubelet 1.14 or 1.15, you also have these problems. So you may, it's more on predictability. So that's why it's recommended to have these versions all together. But some people decide not to do it. But if you do, you have to be careful of watching for these versions queues. Similarly with kubectl, if you have an older version, say you're running Kubernetes 1.17, but your kubectl is 1.15, and maybe you're using kubectl in your CI/CD system to do tasks, to do deployments, and then maybe things will not work because it's not compatible, right? So there may be some issues there. Same with the other Kubernetes components like the controller manager, the scheduler, etc. So what are some of the solutions for these Kubernetes clusters upgrades? So first you have that in-place upgrade. So this is a control plane. And then you have that 117 version, like we described in the beginning. And you have all these components with 117. So typically, you want to do the upgrade gradually, right? So initially, you start with your nodes or your main nodes that are not the leaders. Okay? So you start with the nodes on the left and the right here. So the leader is still there, so potentially you can still make decisions. If you have a 4 or 5 node Kubernetes control plane, then you start with the nodes that are not the leader. You identify which one the leader is. And then you upgrade that leader. But when you upgrade that leader, these components have to be restarted. I'm also not showing etcd here, but also a lot of people run etcd in their control plane. So that component is also restarted. And when that happens, that's not the leader anymore. So typically a new leader gets selected, right? So maybe the one on the right becomes a new leader, right? So when this happens and you're doing the upgrade, you have workloads running and maybe things being scheduled. So you might run into something like this. So you have crash loop back off in some pods. You have some containers or pods running in pending state. Some of them running with no problems, but then some things are not going to work the way you want to. So another solution, having blue and green clusters. So in this reply, Kelsey Hightower last year said for this type of issues, when you upgrade, it's better to have more than just one production cluster than your actual only cluster. So the solution is to have a blue and green cluster, ability to switch between different clusters. But you can also use that for Kubernetes upgrades. So in the blue and green cluster approach, you have your main nodes here, and they're running 117. Also with the same components running 117, API server, the controller manager, the scheduler. And then you have a completely different cluster with all these components, again with 118. API server is 118 here. So a completely separate environment. So this is your control plane. And then you have the two different control planes separately and side by side. And you can gradually, if you have them side by side, start copying some of the workloads, say from 117 to 118. So you have your deployments, your stateful sets, your pods, your secrets, whatever you need to run your workloads, and then you copy them over to the new cluster. And then once you're done copying over all these workloads, you can just get rid of the old cluster. And so get rid of your blue cluster. And this can happen interchangeably. So now 118 becomes your green, and then in the next Kubernetes release, you could have a blue cluster that is 119. Similarly, you do the same for your Kubernetes data plane. So you have a Kubernetes nodes. You move your workloads from the ones running 117, or you copy them over to the nodes running 118. And then when you're done, you also get rid of the 117 nodes, and you're done. And maybe you can start up a new Kubernetes cluster. If 119 is out there, you can start a new one to be ready and for the next upgrade. Of course, you need to keep up to date with the different patches of that 119 version if you want to keep that cluster running for some time. So other blue and green approaches or tools that you can use for blue and green cluster upgrades, you can use Federation V2. Right now it's in alpha. So it allows you to have Kubernetes clusters in different regions. So you could have a Kubernetes cluster in California, and then a Kubernetes cluster in Oregon, and then do that switch over that way. So you have federation, and then using these tools to help you out, migrate some of the workloads and do the switchover. Also, Linkerd has cluster mirroring that allows you to have a Kubernetes cluster service on one region and then make it think that that service is local when it actually is in a remote place. So you have a cluster in New York and has a service there, but the service actually maybe lives in a cluster in Chicago. And obviously, Cluster API, widely used project from the Kubernetes community that allows you to manage Kubernetes clusters using a Kubernetes cluster. So you can manage your whole fleet using Kubernetes itself. So let's talk about some tools that you can use for these upgrades. So when it comes to upgrading the Kubernetes components, the add-ons, you use several of them in your cluster. You have the cluster autoscaler, you have your monitoring, you have your log aggregator, all these different components. You can use any language that you like. I mean, you can use Bash, Python, Go, or Rust, whatever language of your choice. So you need to find a way to manage these components in an automated way. There are other tools, for example, to provision your clusters. You can use Terraform if you're running your clusters in different clouds, maybe AWS or GCP or Azure. Or you can use something like EKS-TTL from Weaveworks, and you can define your Kubernetes cluster in a YAML format. Flux is another tool that allows you to have this kind of GitOps approach for applications, but you can also use it for Kubernetes components, right? So you can use it for your cluster autoscaler, your core DNS, your network overlay. If you want to keep up to date and maybe there's a feature, or maybe you're watching a container registry and then you want this to get updated automatically, you can use something like Flux. So in this example, you have a GitOps approach with Flux. You don't necessarily have to push a commit, or maybe not necessarily push a container image. You may choose to do so, but you could also have it look at a container repository, a global repository, and pull those images from there or make a change based on that. So you're always up to date. But you have to be careful which components you want to upgrade and maintain with the latest version. Another tool from Weaveworks is WKS-CTL, and it's basically GitOps definitions for Kubernetes clusters. It's still a project in the works, so you can do your state and Kubernetes cluster state in a YAML file, and it supports multiple Kubernetes versions or cluster versions. For example, it supports Firekube, which is running Kubernetes in Firecracker VMs. Vagrant, running Kubernetes locally. Footloose, allowing you to run Kubernetes in containers. There's no AWS support yet, but it might happen in the future. Another tool is Keiko. This is from the open source team at Intuit, and it allows you to manage your worker nodes in Kubernetes. But the only gotcha here is that it supports AWS. So it has some really nice components to help you out. You can manage your SLAs. You can bootstrap your Kubernetes nodes. If you provision your Kubernetes cluster with a different tool, not necessarily like your cloud provider like EKS or GKE, this is a great tool, say, for AWS. You can also optimize the cost of your cluster. You can do security with forensic dumps. So these are the components for Keiko. So you have your monitoring, cost effectiveness on with your minion manager. You can manage reliability with your governor. You can do the orchestration of upgrades using the add-on manager, upgrade manager, and instance manager. So all these different components to help you out. Other tools that are really popular to manage Kubernetes clusters are GitOps, written in Golang, has been around for a while, has a very large community, supports multiple clouds. Kubespray is another tool. It's basically deploying Kubernetes clusters using Ansible. So you can use it to deploy blue and green clusters the same way with GitOps. Linkerd has this feature that I mentioned before, traffic mirroring, and allows you to have services across different regions. So you make that switch over easier and run, in a more effective way. Pluto is another nice tool that allows you to see the different Kubernetes versions that are getting deprecated for the different resources. So in this example, you see deployment at the top. You have V1 beta 1 and V1 beta 2, and then V1 beta 1 says that they were deprecated in 1.9.0, but they were still available up until 1.15. So in 1.16, they're completely removed. So you can tell when you want to change your resources or how far ahead you want to change your resources. Prevents you from saying, like, you're moving from 1.15 to 1.16. Say if you have an API definition for deployment that says V1 beta 1, and then you upgrade, then that resource may not work because the replacement is apps V1. So your deployments may not work. So what does it look like in production? Running all these automation tools in, say, production environments. Ideally, you want to have automation everywhere. I know most people don't have this. This is where you want to get to and what you want to strive for. So you want to have that full automation of your control plane, provision all your nodes, all your main nodes with all the different components, your data plane, your worker groups ahead of time, fully automated, verifying them. Then also your add-ons, your cluster autoscaler, your networking add-ons, all these different things. You want to have them fully automated. Maybe have the blue and green switch over if you have stateless applications do happen automatically. Say you are running an external facing application, a website, and it's serving millions of users, then you can have a tool that maybe switches over that DNS automatically and does the verification. Okay, you're getting all the right requests, right? So, and it allows you to roll back if something goes wrong. So what about stateful applications? So yeah, maybe you want to use a maintenance window. These are very tricky applications because they have your data. So you want to make sure that your data is not corrupted when you do these switchovers. So create a lot of replicas if you can, depending on the stateful application you're using. Say you're using something like a MySQL, you can create another set of slaves, and eventually when you move to that new cluster, you could have that slave and promote it to a master, and then move the other slaves later on. Make sure you back up all your data, so in case your data gets corrupted. So this is very critical. Use tools like snapshots in cloud providers, or if you have storage systems, take some snapshots, back up your data. So what does it look like in terms of the future and what you'll see with these tools and Kubernetes cluster upgrade approaches? So we'll see some tools maybe to fill in the gaps. So we talked about automatically switching over your DNS provider when you're running website type of application or web services. So tools that allow you to talk to these DNS providers, maybe talk to the load balancers, and then do that switch over. Tools that help you do stateful application switchover. We talked about the data, maybe tools that will back up your data automatically, make sure that data is correct. Keep in mind that there's a lot of operators for stateful applications nowadays, but most of these operators are limited to just a single cluster. So maybe we'll see some of these operators extend some of the functionality for multiple clusters and being able to migrate from one to the other. Also, maybe tools that fill in monitoring for these upgrades, making sure you're hitting your 200 status codes on your HTTP services. Also making sure that your security policies are correct, like your network policies are not allowing certain IP addresses, or certain pods can talk to each other and some of them cannot. So all those type of things. So fill in those gaps. So from the cloud providers, we'll also see maybe more tools. In this example, we see EKS. On the roadmap, you see one-click full cluster upgrade, maybe allowing users using EKS to just do a click and automatically test everything that is in cluster and seamlessly do the upgrade with no downtime. Of course, you still want to test it and want to make sure that everything is okay, but then that's where the direction is going with some of these cloud providers. So more ways to manage your nodes too, like if you want to, upgrade a patch on your node, that type of thing, some of the tools will make it easier. So what can you get out of all of this? What can you take home? So when you want to do your Kubernetes cluster upgrades, you always want to start with a small cluster. Don't go full blown on a large cluster and try to upgrade that. So make sure you test in a constrained environment. And use a QA environment, for example, never in production. Leverage some of the existing tools in open source, Terraform, Flux, Keiko. When you create these new clusters, make sure that the version is always the same across the board. Your kubelet, your kube proxy, your API server, your kube controller manager, your API scheduler, your cloud controller manager. So all the different components in Kubernetes. You have kubectl convert that allows you to convert your API or manifest files ahead of time. So use that. And then use something like Pluto to identify whether you need to do those changes. You want to make sure that when you created your green cluster or your brand new cluster and you copy the workloads, you want to test that the API endpoints or whatever workload you're running there is not crashing, is returning OK requests, all those different things. So test across the board depending on your application. And make sure to back up your data everywhere. Back up everything, especially if you're running stateful applications. So with that, here are some resources for some of the tools that I talked about. And yeah, and that's it. Thank you very much for your time. I'd be happy to chat more about this topic. This is very interesting to me. We use this on a daily basis. So if you have any problems and if you wanna, discuss, and I'd love to, see what problems you have and what solutions you're thinking of, and how you can, make these things better. So thank you, and with that, I'll leave it open for some questions.